Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Good day or good night, wherever you are, whenever you are watching this. My name's Kevlin, Henney. We are recording this GOTO Unscripted session at GOTO Amsterdam 2022, rescheduled from 2020. And I'm joined by Holly Cummins, who is Senior Principal Software Engineer on the Quarkus team at Red Hat. Holly, welcome.
Thank you.
And you're here, you're going to be giving a talk which kind of brings a whole load of concerns together. So could you tell us a little bit about it?
Yeah, the title of the talk is Cloud Chaos and Microservices Mayhem, which is kind of reflecting some of the experiences that I've had in my previous life with IBM as a consultant in the IBM garage. And one of the things that I've seen is that we've been talking about cloud for a long time now, but I think as an industry, we haven't quite caught up to it yet, and we're still getting these things where the assumptions baked into our technology don't play well with cloud. Or, so there's sort of the technology side, but then there's the people side, which, as we all know, is harder. So we've set up all of these processes to try and make software engineering safe and reduce risk, and they were a good idea until the cloud came along, and now they're a terrible idea.
Yeah, so that we're seeing, as you said, we're kind of well into the cloud era. I mean, if we can stretch it liberally back to about 2 decades and say that we've got that, but we are still, if you like, at a relatively youthful stage in terms of the infrastructure, what has become standard, in terms of what a developer can rely on. But you know, if we're talking about that, then we're also talking about what are most developers using, their day-to-day languages and their stack and so on. There's a kind of as you said, the people are the harder bit. It's the practices as well as some of the tools. So what are, this is a really big question, packed as a little question. What are the challenges that you're seeing? Because it's obviously not a case of like, hey, here's cloud, it's just like moving to a different OS. You're familiar with this, therefore this is identical. It's not. What are the challenges? What are the big hiccups or that you're seeing?
So some of them I think we're sort of a bit further along with, but there's a whole bunch. So tracing and logging is something that I think we're kind of getting to grips with. So I think probably all of us had the experience when we first started doing cloud, that we had everything going out to the logs, and then the container died, and it took the logs with it. And then we went, wait a minute, I needed those logs, come back. And so we had to learn, whatever you do with your logs, make sure they don't stay on the container, they have to go elsewhere. And then there's the next step up, which is, yes, but my application isn't just one container, my application is 600 containers. In order to have any hope of diagnosing a problem, I need to have some sort of correlation between what's going on in all these containers. So I feel like we're maybe now entering a bit of a golden age of observability, where we are seeing a lot of tooling maturity, and we're seeing sort of the integrations and the convergence. So we've got the open tracing and the open telemetry, and they're kind of getting there. I think the adoption is maybe a little bit behind the standards. So every observability talk I go to, the speaker will usually ask, so who's using observability tools? And there'll be sort of 2 sheepish hands that go up. So adoption's lagging a bit behind, but at least we know what we have to do on that one. Whereas I think on some of the other ones, we don't really even know what we should be doing yet. So things like releasing, I think we're still figuring it out. We have a feeling that we should be releasing more continuously than we are, but we're not totally sure how to manage the testing for that. We're not totally sure how to manage the risk for that. We're definitely not sure how to persuade the business that we've got a handle on the risk, because that goes back to that process thing where the business is using the processes that made sense 10 years ago. They may not make sense anymore. But then you sort of start to get into this sort of horrible world of versioning. Because even if you get everything right and you've got the continuous delivery and you've got the continuous deployment, if someone is consuming you rather than just you're a web app, do they really want you to be doing continuous delivery? How do you guarantee the compatibility? Should we be going back to semantic versioning? Should we? So there's sort of, I think, a whole bunch of questions there that none of us really know the answer to.
I think it's an interesting thing that you're bringing out there, which is a lot of this is coming down to mental models. It's a collision of mental models. You described exactly that. The issues with logging is because as developers we hold a mental model of how the machine works, how our program works. This is how code works, and I do this. And we have this mental, even when we don't explicitly externalize it, we have a mental model of how all this fits together and how it works, and every developer, depending on their own career path, picks up a mental model. And you don't really realize you have those assumptions until they collide with something that tells you that was an assumption. Your assumptions are discovered by contradiction. Oh, I had assumed that. At that moment, you had an assumption. Oh, so the logs went with because it was in the container, it was contained. Okay, so therefore, that's an assumption. But also you're talking about the business having particular assumptions as well. Here's the things that work for us. And in business memory, sometimes 10 years feels depending on how they look at it, it's either timeless, this is how we've always done it, or didn't we just have to adopt a whole load of stuff? For people with longer memories, they're going, well, you want us to do stuff again, but also that idea of meaning that you're bringing out. I think the versioning thing is an interesting one, because when we talk cloud, there's a whole, almost like word cloud, you say cloud, and actually there's a whole set of associations, and buzzword bingo is played effectively, and so that can be quite bamboozling. But it's a case of like there's already a lot of stuff that I have to depend on. That has versions, and then I'm offering something, and that exact question that maybe other people don't want us to continuous delivery. The downside is potential for continuous disruption, and normally people say, really, just stay still. We're building an application here. Stop moving around, and that's a big challenge.
I think that the idea of mental models, actually, I really like as a way of thinking about one of the other things I'm going to be talking about, which is microservices. And I think that some of the challenges we see with microservices, I think, have exactly to do with the mental models. So the promise of microservices is your mental model can get a lot smaller. Instead of having to hold the whole application in your head, all you have to do is hold this small piece of the application in the head, and as long as it's correct, the system is correct. But of course, we all know it doesn't work that way. You can't make a correct system by just making lots of correct individual parts. And so then there's this sort of contradiction between the promise of you have this very small mental model and, actually, no, you have to hold the whole thing in your head. But it's kind of quite hard to reason about, and it's actually probably much harder to reason about than it was before the shift to microservices. And what do we do? How do we make this work?
Yeah, and I think that for a lot of developers, and the reason people move to microservices is sometimes it's why are you moving to microservices? Well, because everybody else is. That's not very compelling, but it is. I'm going to say it's not unknown. There's a lot of people doing that, and so therefore it means that they perhaps those people are not really prepared for the surprises. The fact that you're now suddenly saying, everything that you could rely on, you can't. There's latency. There's failure modes that you never even dreamt of. When I call, if I'm in a single process space, and I'm calling a method on an object, there really is nothing that can go wrong with the call of that method. I don't sit there going like, I wonder if the dot doesn't work. It's method. I take my object and object.method plus arguments. I'm expecting everything. I have a very simple mental model of how that works. The dot works. The delivery construct works. It's built into the language. Unless the reference is null, in which case the null handling works. There's no surprises there. It all works. And I have a very simple model. I get the results back. It's all synchronous, single-threaded, utterly, quite genuinely reasonable in the original sense of the word reason. And then we say, okay, microservices, let's divide this up. And suddenly it's like, you can't rely on the dot, that whole thing. Actually, the delivery mechanism, that's a little more complex as well. Don't assume that these are all synchronous and ordered either. And where's your data and what's its quality is. All of these are potentially confounding. It's not that there aren't benefits to be had, but I think sometimes people are going they underestimate how much of a shift that is to their day-to-day programming model.
And I think as well, I think sometimes we end up in this sort of worst of both worlds situation where you have all of the costs because those are non-negotiable technically. You can do the right thing to manage them and you know, get a service mesh or something to try and help, but fundamentally those don't go away. But often you get the costs without the benefits because one of the benefits of microservices is the independent deployability, but then that's kind of scary. So then you still release everything in a batch, and then at that point it's not like a double win, it's like a double loss.
Yeah, and I think that is the interesting thing, where that whole, you know, what's the value proposition? There's certain scaling properties, the independence of deployment, all of these things, and then you sometimes ask people, and it's just like, yeah, we don't need to scale. It's just like, well, why are you doing all of this? You know, it's but we've also got, you know, we need to deploy everything all at once. Or you talk to people and you have this kind of conversation about how frequently are you deploying, and it's just like, and it comes back every few weeks, and it's just like, maybe microservices is not where you're at. If you're getting friction in your dailies or multiple times a day, oh yeah, you need to be working in this space, but that's not where people are. So there's a little bit of fashion driven. So I get the sense that in the microservices space, and I was talking to Fred George about this one, there's people who are genuinely going for the kind of the original vision. Oh yeah, that partitioning down, that independence, and I understand the costs, and it's that kind of, there's a trade-off, you know, that the literal sense of trade-off, it's a trade. You know, it's like, oh yeah, I'm prepared to pay the cost because I'm getting these benefits and I'm actively using these. And there's people who are pursuing that, and then there's other people who are kind of like, well, you know, conference-driven development. Everybody's talking microservices, but as you said, when you go into these things and you ask the architectures and the tooling and who's doing this, there's only a small smattering of hands, but there's a lot of interest. But sometimes people are walking away going like, well, we need to be doing this. And they only pay the costs because they don't need those benefits yet. Maybe they do a little further down the line, but they find themselves in a surprising new world of clashing mental models, and they're trying to sell it to the business as well.
Yeah, I think often nobody wants to be the one who says, it's 2022, but no, we're not doing microservices. But I think, as you say, you have to sort of go back and, what problem are we trying to solve?
Yeah.
No, really, what problem are we trying to solve? And sometimes when you drill down, then the problem we're trying to solve is everybody else is doing microservices. And it's like, well, is that really a problem?
Yeah, that's right.
You decide.
CV-driven development, yeah. And again, it's that idea of appropriateness and context. And I think that the modern software development modern software developer is challenged by this ridiculous amount of stuff that they have to know or could know. I mean, the landscape is vast. And you know, if a software developer enters in the mobile world, they may never have to worry about what's going on at the back end, if that's their concentration. Or embedded developers, they see a very different view. And so there's so many different parts to this landscape. And so therefore it's very easy to say, well, those people over there are doing this, maybe I should be doing this over here. Maybe you should, but maybe you shouldn't. But I think that brings another challenge. The poor developer in the modern landscape, because there is so much to know. There's no way anybody can know everything. And I think a lot more these days people have been talking about the developer experience, you know, just trying to recognizing, and I know it's something that I've been quite keen on for a while, is this idea of, as a developer, I am a user of the tooling. As a developer, I am a user of our programming guidelines and conventions and our practices. I'm a client of that. What do I want from it? What can I get from this? What are the things that make life hard for that? But also, what can be made easier? Because the move to cloud is, you know, because there are so many things. Because literally, it is a shopping list. It's a word cloud of possibilities and technologies. It can be quite confusing.
And yeah, it's such a good question. And we're sort of having this conversation about developer experience more and more now, but I think the reason that we're having it is because at the moment the developer experience in our landscape is pretty poor. And I think sometimes we end up again with a tension between fashion and developer experience. So if you look at Kubernetes, for example, it is fiendishly hard, and it is much harder than some of its predecessors like Heroku and Cloud Foundry, and it gives you a lot more in terms of the flexibility. But sometimes we paid that cost, and we didn't actually need those other benefits, but no one wanted to be the person who said, actually, I'm kind of dumb, so could I not use Kubernetes, please, right? That's not a conversation you want to have with your management. So then we end up sort of all, in order to, prove we're tough enough for Kubernetes, we sort of race towards Kubernetes, and now we're sort of doing that reset and say, wait a minute, does it have to be this hard? Couldn't we make it a bit easier?
Yeah. Just because something can do everything doesn't mean you want to do everything. I think that's the interesting challenge, is that we are normally in development, we're brought up on a steady diet of abstraction and generality and all this kind of stuff, and therefore our platforms inevitably reflect that, because they are trying to be, in some sense, general. It's like an operating system. It has to be. It doesn't know who its users are, and it doesn't care. It has to be providing all of this, but to fully know it. And that's the problem, is that there are so many different things, and nobody wants all of these things, or rather, no, let me rephrase that. Nobody needs all of these things out in one go. So they've got this huge, overwhelming learning curve. It's massive.
The sort of the marketing towards what people want rather than what they actually need reminds me of, in a completely different domain, when Febreze launched. So Febreze, you sort of spray it around and it eats the odors by a magical chemical process. And when it launched, it completely flopped. And the reason was because their sort of marketing, the subtext of their marketing was, are you kind of dirty and a bit gross? If so, this is the product for you. And even though there were people who needed it, nobody wanted to be the one who said, actually, I'm your demographic. So they changed how they marketed it, and they changed it. So, are you really quite clean? This is sort of a nice little thing that you could do after cleaning as like a little treat. You spray Febreze round. And so it was completely inappropriate for the actual capabilities of the product. But people wanted to be the person who was buying it.
Yeah.
And I think we sometimes see that with some of our technologies as well.
I think I think you've actually hit the nail on the head there, because there is this idea that normally whenever anybody is pushing a technology, no matter what its specific possibilities are, either the people that need to see that don't see it. It's just, actually you are the demographic. This would help you, or it gets marketed more generally or pushed more generally. In other words, hey, this solves a specific problem, but now let's push it to a broader thing. So, and that I think is, I think that's a very human thing. But I think again, it presents us with that challenge as a developer. Let's just say that I've graduated. I've spent the last few years at university. I've been doing a couple of languages. I've learned a few paradigms. I've got a bit of Java and got a bit of Haskell, and suddenly discovered that actually the job market has precisely zero interest in Haskell. And I've got my Java skills in there, and then maybe I did a module on machine learning. Maybe I did whatever my final year was. And I come out into the world and I'm presented, here's this mobile space, here's this cloud stuff, and then there's this embedded stuff over here, and there's all of these things, and I'm confronted with full stack development and again, that term is particularly interesting, because the full stack, where does cloud live in that? Really, does that mean I have to know everything about Kubernetes? That kind of thing. How full is my stack? I'm presented with all of these possibilities, and that's hugely daunting. What do I do with my kind of raw programming skills? What do I do with the stuff I already know? Where does that take me?
And I think we have another challenge as well, which is a slightly different one, but I'm sort of quite conscious of it now, which is that we're starting to build up not just a legacy in our industry, but we're starting to build up a legacy on the internet. So now if I go and I Google, how do I do a REST service? I find so many wrong answers that, sort of seem to ignore the possibility of JAX-RS and that kind of thing. And you're doing it at this really low level, and it's like, no, don't. There's higher level APIs, but they just, there's all this sort of cruft of knowledge that's obsolete that we don't really know how to get rid of yet.
Oh, so there's a geology here, isn't there? There's a kind of time strata, and that the internet, as a source of wisdom, may accidentally reinforce where the problems are, and that becomes quite interesting. And as you said, there are higher level abstractions, but when somebody Googles a very specific question, perhaps they don't know that. It's one of those things. sometimes in somebody's question, they're actually asking something else. It's just like, actually, you didn't want to be operating at this level. We now have this. That's how we do things.
What problem are you trying to solve?
Exactly. What problem are you trying to solve? Because you're actually giving me part of a solution. You've anchored on a solution. And we are very solution-centric in this discipline. So you've anchored on a solution, so you're asking a question about the solution, whereas actually if somebody took a step back and said, actually we can unask that question. If you use this technology or you use this frame, where you want to be pitching is at this level, for which what the question you're asking has already been solved. And there is no way of and that's not just a case of the stuff on the internet's old, it's the way we ask our questions, that frame of knowledge. So kind of relating to a bit of that and the age and the accumulation of things. So a couple of years back, you contributed a couple of pieces to the book that Trisha G and I edited, 97 Things Every Java Programmer Should Know. And you had a piece in there, Java should be fun. And at the moment, so just sort of recapping where you are with Quarkus, that's basically trying to bring the Java world to the cloud more comfortably, as it were. And you made a number of really interesting points in the Java should be fun piece, one of which was you distinguish between fun and unfun. There are things that are unfun, it's just like boilerplate code, stuff like that. There's a certain tedium to things. And then there are other things that are fun, whether or not they radically change the way we think or whatever is not the issue, but they make it engaging for the developer. It's just like when Java introduced lambdas, then suddenly lambdas and streams kind of loosen things up. Maybe they don't really change things at one level, but maybe they do at another. They make it more enjoyable. But you also acknowledged the age of Java, because it's not young anymore by any stretch of the imagination, but it's everywhere, and that's the thing, is people are coming out of wherever they are with, it's a classic back to work training skill. But the world in which the Java of the 1990s, when Java came in, it's just like, hey, you can write applets. It's like, well, if you tell people now, they don't believe it. It's just like, really, you're supposed to write stuff in your browser. It's just like, but how did that ever work with that? It didn't. But it was a marketing ploy.
Yeah.
But then we see how Java has evolved through all of these things. We see it at the back, and it's all the way through that stack. And now we're throwing it into the cloud. Isn't it a bit much? Isn't the poor Java programmer, that's bewildering.
And I think, yes. But I think there's sort of, Java's in a really good place at the moment. It does feel like it's having a bit of a renaissance, and I think it's now got what I think is probably quite a humane release cadence, which is not so fast that it causes terror and panic, but not so slow that you're sort of there, just sort of weighed down going, but can't I use? And then we're some of the sort of like what Quarkus is doing, I think is really interesting, because it sort of satisfies a personal belief of mine, which is that often you can solve two problems at the same time, which is really quite nice when that happens. And we saw a similar thing in the opposite direction when I worked on WebSphere Liberty, which became Open Liberty. The problem we were trying to solve was the developer experience, because classic WebSphere was very much optimized towards running on big iron and optimized towards the sort of the administrator experience. And so then when you were developing on it was, you needed quite a significant piece of hardware, and, it was a bit slow, and it was like, come on, surely we can do better than this. And so we made something that had an OSGI kernel, and so it was really sort of, it had the same libraries as traditional WebSphere, but it was light and fast and delightful to use, and it started up in a few seconds. And that was just sort of when cloud was just really starting to take off. And then we discovered, oh, wait a minute, this thing that we wrote to have a really good developer experience happens to have exactly the right characteristics for the cloud as well, because it's small and light and starts up quickly.
Right, yeah.
And with Quarkus, they've kind of gone in the opposite direction, and they've said, what would we have to do to make a really good runtime for the cloud? It's got to be really small. It's got to start up quickly. And then in order to do that, what they've done is they've shifted to doing a lot of the stuff.
Yeah.
at build time rather than at runtime. So all of the annotation scanning, all of that normally happens at runtime and is kind of slow. They've said, okay, well, let's do it at build time. And in order to make that work, you've got to do the bytecode manipulation. And then they've said, well, wait a minute, while we're doing the bytecode manipulation, there's all this boilerplate. And we had that boilerplate because to not have it would be too slow. But now that we're doing everything at build time, we can get rid of that boilerplate and get this delightful developer experience. So then one of the things they talk about is developer joy, which exactly goes back to Java should be fun. Of when you see this kind of boilerplate, almost always it can be automated away.
Yeah. I think that's a really interesting. Also, there's a kind of about how we move, how things. Not everything moves in one direction. It's kind of like I think if you stand back from the industry and watch it over longer time periods, things slosh around. So an example of the sloshing around is, everything ran on the mainframe, and then we started having PCs, and then it's kind of sloshed out towards there, and then we kind of reintroduced the network, and there's this kind of like old style kind of wave machine moving. Mm-hmm. Where's the center of gravity of my application? And it's just like we're moving a lot more intelligence into what's in my hand. But then now we're realizing well, actually, I'm going to move a whole load of other stuff back again. It keeps going to and fro. But also there's another timing thing about when we do things. So Java is a static language, but has a very dynamic element to it that is resolved at runtime, optimized at runtime. But then you're saying, it's like, okay, well, let's pull some stuff back into the build stage, which is, as it were, it's offline for anybody they don't see that. When you're running that, you don't see that. That's that development time stuff, but it's not runtime stuff. So if we move some of that back, then that means we have a slightly faster runtime. This is kind of sloshing to and fro, which you don't get as much with, say, a dynamic language, whereas we push all of that back to the runtime because perhaps it doesn't cost us as much for certain scenarios. But there seems to be this kind of sloshing movement. And one thing I was looking up on Quarkus was their startup times were really good.
Ridiculous.
Yeah, really good.
Completely stupid.
Yeah, and that's the whole thing, is that there's kind of like literally a latent expectation, an expectation of latency with certain things. And that, going back to the developer experience, that changes the feedback cycle, doesn't it? Which I guess if we look at the bigger developer experience, that kind of takes us back into like, well, one of the reasons sometimes people object to or resist, subconsciously sometimes, say testing, is they're saying, well, that's a slow step. That takes too long. And that's something you're talking about, isn't it? Is the testing side of things. How does that kind of fit into that cycle, as it were? How does it kind of conveniently fit within that? Because if people feel there is an obstacle in their way, then they optimize the obstacle out of the way. And if they perceive testing like that, they kind of move it out of the way if they don't test.
Yeah, there's sort of two sides to that. One sort of continuing with the Quarkus side is so they've done some really interesting things. Again, I think because they had sort of that that problem that they were solving, and then they were in the bytecode. If you move everything to build time, then your build times are going to be longer. And so then they said, well, you can't possibly have a development experience with long build times. So then they had it all be sort of quite continuous and dynamic. So you run it in dev mode and it's just instantaneous. And that's true for the testing as well. So they've done a quite clever thing where they have this thing called continuous testing, and it uses similar techniques to code coverage. So instruments your code. It knows what tests relate to what code, and so if you change that code, it will run just those tests dynamically. So again, you get that instantaneous feedback, even though you're in this sort of notionally quite static mode. So that's the sort of the one side, but then there's the sort of the psychological side of it as well. And I think part of it has to do with how bad we are at accounting for costs, and if something is visible, we really see it. This is the most inane statement ever. If something is visible, we really see it. If it's invisible, we don't see it. But I think when we do something like testing, it feels like an upfront cost to write the testing. But if instead, sometimes I'll do something and I'm trying to shortcut and I won't write the test, and then I find I'm like in the browser just going refresh, change, refresh. And I'm like, if I had a test running, this would have saved me all of these steps, and I would have known much more quickly actually whether it was working. But because there was that sort of small upfront cost, it feels like it's more expensive, even though actually it saves you so much down the line, even before you get to and I've just regressed it in production and I'm doing a demo in 2 hours and I need to fix it, and all of those kinds of horrible embarrassments.
I think you're right that the visibility thing is not, if it's visible you can't see it. Well, that's not to be underestimated, because there's an awful lot. The nature of software tells us that we can't see everything about it, that most of the ideas are genuinely in our head. And so therefore we don't notice those little things. We don't notice that thing that, because it took time, we don't realise where the time might be saved. And because it's also probabilistic, in other words, it's not guaranteed. If I write a test, there is no guarantee that I have eliminated all bugs or whatever. That's not a guarantee. So therefore it's about probabilities. And we are very, as humans, we are very poor at that, and we're not very good at attributing that. And then exactly as you say, you can get caught into this loop. And if you're not careful, you become so familiar you don't even question it. And that was, I certainly had that with experience years ago when it was one of those trying to break the loop moments. It's like, we spent all morning trying to do something, why don't we, what about these other tests? It's like, oh, we don't bother with those tests because they take too long to do. And I said, well, we've just spent all morning repeatedly poking and prodding this. Perhaps a test would have saved us most of the morning. And it's that notion of we're not very good at attributing it, but because it had become reflexive, by that point we don't see it anymore. And I think that becomes, again, it moves from initially annoying and visible to surprisingly invisible.
And I think, it's gruesome, but it's completely the frog boiling thing, isn't it? That you don't notice it because it's so gradual. And I think that's what we see with the complexity in our industry as well, is that the complexity builds up and up and up, and then eventually we'll get a disruption where someone will say, wait a minute, it doesn't need to be like this. So, this is what Spring did many years ago, is they said, J2E, there's no way it needs to be like this, we can fix it. And then, I think now we're sort of in another reset as well, where Quarkus is sort of saying, look, it doesn't need to be like this. And I think we're still waiting for that with Kubernetes so in other words, it doesn't need to be like this.
Yeah, there's a post-Kubernetes is going to happen at some point. So I think, but that's an interesting one in that sense of that compounding complexity. Now, one thing you are also talking about is the testing side of things, with looking at the contract testing between the parts. And that seems quite an intriguing thing, because as we open talking about, say, microservices as the parts, I can individually reason about them, but the relationships are a little bit looser. They are perhaps a little more, we have a blind spot there, because something like a protocol is not a thing in the way that we normally think about code. And yet, if this expects something that this is not going to give it, that's kind of fundamental. It's not unit testing, but it is still, there's a kind of a gap there. How do you think we're moving forwards on that?
It's a question I ask myself as well. So on paper and in theory, contract testing fits an absolutely necessary middle ground between unit testing, which doesn't identify the problems with the system, and integration testing, which does, but which is so expensive and you shouldn't do too much of it. In practice, contract testing, in my experience, most people haven't done it, and quite a lot of people haven't even heard of it. And so then the question that and it's an open question for me, is why aren't we doing more contract testing? Because this is clearly solving a problem that we have created for ourselves with microservices, which is I have no idea if the system works. How am I going to know that? I need something that's in between those two. But I think it can be quite hard to get your head around. In order to do good contract testing, both sides need to talk to each other. And I think that challenges one of the assumptions that we had when we went to microservices, which is I'm going to microservices and that means I don't need to talk to any other team ever. Well, you kind of do, because you're kind of going to need to deploy together. And so I think that's the sort of the barrier to contract testing.
So that, in other words, we've kind of come back to that kind of classic thing, is that ultimately architecture is a description of, as it is with buildings, it's how people are able to flow through a space, or rather how they're able to work together. And that microservices are not going to be truly independent, that because I need you to get my work done, this depends on that, and so on. So there is this idea that we're reflecting something of the social complexity. Well, I was going to say social structure, but actually let's cut to the chase. The complexity of people. The fact is, what is our understanding between ourselves, to be reflected in code that we can rely on I understand that you're sending something and this means this to me and this means that to you. We're talking about the same things. We have the appropriate expectation over time of how this is going to behave. But that's also a people thing. I mean, I can render it in curly brackets at one level, but again, it comes down to the people thing, and that perhaps is you talked about the people challenges. In other words, it covers mental models, but it also covers how we work together. The architecture reflects that.
Mm-hmm. And with contract tests, if I make a change that breaks you, what I really want is my build to break, and that, I think, well, in theory, I want my build to break. In practice, I don't want my build to break ever. And so I think people get uncomfortable with contract testing because the idea is that you could do something and my build breaks. And it's like, well, no, I don't want my build to break because of you. But of course, if you don't do it at build time, you're going to do it at production time, and that's where you're going to have the break, which probably isn't where you want the break.
And that's an interesting thing. Again, it's the identifying the different roles, the different individuals, but technically the contract captures the space between us. And that's, I think, an organizational challenge, because we have historically, no matter what ownership models people tend to use, there is this, well, that's ours and that's yours. And then what does the contract, and this one I guess I've struggled with in various different architectures and approaches over years, is conveying to people, this is the bit that is shared. And that means that it can either be something that collectively we are really good at, or we collectively disown it, collective disownership, as it were, like it falls between the gap because we jointly disown it, we jointly unshare it, so to speak, and the contract trying to be this thing that is between the two. Okay, so that kind of brings us kind of full circle to the idea of we're kind of like, there's the people, there's the technology. We've kind of taken them through the layers and back out through the complexity with some potential solutions. So hopefully you found that useful. Please check out Holly's talk when it becomes available. And thank you very much. Thank you, Holly.
Oh, thank you, Kevlin.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.